Hello everyone, welcome back to my channel. If you are a fresher preparing for your first technical interview, or even you are just starting your journey in computer science, this video is made exactly for you. So today we are going to cover one of the most important and most commonly asked topics in any technical interview. Okay, so let's start with the what is data structures. Okay, what are data structures, how they are classified, okay, what are algorithms, what are flow charts, okay, and how to analyze an algorithm using a big O notation. Okay, now by the end of this video you will be able to answer any interview question on these topics with confidence. Okay, now without wasting the time, let's get started. Okay, so just we'll just understand what is a data structure. So before giving you the exact definition, technical definition of the what is data structure, let me give you a real-time example. Okay, imagine you are just walking to a library. Okay, now all the books are organized, right? Where fiction books into one section, science books into another, and textbooks are separately aligned, right? Now, why? Because organized data is easy to find, easy to use, and it saves the time, right? That's exactly what a data structure does, but for your computer program. Now, let's understand what is a formal definition. What is a data structure if somebody asked you in an interview? Okay, so what you should reply, you should say that a data structure is a way of organizing, storing, managing the data in a computer so that it can be accessed and modified efficiently. Okay, now let me break it down. So I said a data structure is organized, right? What is meant by organizing? It means that organize arranging the data in a logical way. Okay, now what is storing? I said a data structure is a way of organizing, storing. Where are you going to store? You're going to store it in the memory, right? And how are you going to get it efficiently? You're going to get it quickly without which wasting the time from the space. Okay. Now, let me actually take one real-time example here. Okay. Let's say 1 second. For example, uh, okay. Now, what is that example I want to take is suppose you want to store marks of 5 students. Okay. Now, without a data structure, okay, without a data structure, how it looks. So you can look in this way. Mark 1 equals to some 85. Okay. Mark 2 is equals to $90. Right. Mark 3 is equals to 78. Mark 4 is equals to 92. Mark 5 is equals to 88. Okay. This is without a data structure. If with data structure, how it looks like? With a data structure, if I use something called an array. Okay, array is one of the data structure. Okay, how it looks, I can actually say it in this way. Marks of, I can define one array where 85 comma 90 comma 78 comma 92 comma 88. Now see how much cleaner the data is, right? Now if you want to access, okay, if you can access any marks using the indexes. For example, marks of 0, marks of 0 is 85. So this is the 0th index. Okay, now this is the 0th index in an array. Okay, this is 0th index, this is first index, this is second index, this is third index, and this is fourth index. Okay, now marks of 0 is 85, marks of 1 is 90. Okay, marks of 2 is nothing but 78, and so on. Now that's the power of data structure. Okay, now if the interviewer asks you what is a data structure, you just don't give the definition. Okay, you can add some real life uh, analogy, like you can say that of a library or a phone contact list. It shows that you have understood the concept and you're not mugged it up, right? So that way it will help you, and the interview might, I mean, he might impress with your answer. Okay. Okay, now that you have already understood what is a data structure, right? Now let's actually understand, let's talk about that its types, data structure types. Okay, so data structures are classified into two types. Okay, one is primitive data structure, and the other one is the non-primitive data structure. Okay, so what is a primitive data structure? So these are the basic data structures. So these are the basic data structures. Okay, these are the basic where uh, actually these are provided by the programming language itself. Okay, they just store the single value, they store the single value, they cannot be broken further. Okay, they cannot be broken further. Okay, now for example, what is an example? We will take int, it stores the whole numbers, right? Example, like age is equals to 21, right? Now float, what does a float stores? Float stores the decimal values, right? Now what is char, what does char stores? Char stores a single character, right? And what is boolean? Boolean stores either true or false, right? So these are called the uh, primitive data structures where they store only the single value. Okay, now let's understand what is non-primitive data structure. What is non-primitive? So non-primitive data structures, these are the complex data structures. Complex structures built using the primitive types. Okay, they store the multiple values. They can store the multiple values, and they represent some relationship between the data. Okay, so they represent some relationship between the data. So now this non-primitive data structures are classified into two types. What are those? One is linear data structure, the other is non-linear data structure. Non-linear data structure. Okay, so what is linear data structures? Okay, so linear data structures are, these are the elements which elements are arranged one after the another in sequence. Okay, so and what is non-primitive data structure? These are, okay, first let's look into the examples of this. Okay, now what are the examples of this? Examples of this is an array. Okay, array which is of fixed size, of fixed size collection of same type. Okay. Now example, we already saw that array int of 5 marks, right? Earlier we saw marks, right? Or we can consider any like 10, 20, 30. It's just full numbers. Okay. So this is collection of numbers. Let's look into the linked list. So linked list is one of the, this is one of the nodes which are connecting the pointers. Okay. These are connected nodes. Nodes are connected using the pointers. Okay. Now how does this look like? For example, okay, 10 connected with 20, this is connected with 30, and if you don't have anything else, so this is nothing but null. So this is some connectivity. Okay, so this is uh, a one of the example of the linear data structure. Okay, now let's look into the next example. Okay, there's something called stack and queues. Okay, what is stack? So it is last in, first out. Okay, and what is queue? Queue is nothing but it is first in, first out. Okay, so I will actually show you one of the best picture which will actually clarify the your doubts there. Just give me a second. Okay, just give me a second. Just give me a second. Okay, just give me a second. Okay, so I'll give you one of the best example which I've just uh, downloaded here for your purpose. Okay, so how does it look like? So classification of data structures are classified into two types. Okay, one is linear and non-linear. So linear data structures example is stack. You can take an example of your plates. Okay, so last in, what you last in this, you take out the first one, right? That's where stack is stack of plates, which whatever the plates which is at the last, that you take it out. Okay, the queue example is this one. I mean, whoever comes in first, he gets out of first, right? So that's why it is called first in, first out. Tree, I mean, it is just like a family of, it's like a family members. So if you have to draw a group of family members, right, animated with oak, right, that is one thing. And graph, you can take this example of maps, right? So it is connected, so A is connected to B location is connected to C. Okay, this looks like a graph. Okay, I hope this is uh, I hope this concept is clear, right? Now let's actually look into the next thing, right? I told you what is linear data structure, what is non-linear data structure. Right, now let's look into the example of non-linear data structures. The non-linear data structures, I told you, I've shown you that this is nothing but tree. Right, tree is one of the best example. Right, so it is hierarchical data structure, hierarchical structure here. Fine. uh, Hierarchical structure here. And graph. So graph, this is nothing but which are nodes connected with the edges, by edges. Okay, I hope this is clear, this concept is clear. Right, now if somebody asks you what classify data structures, you can actually draw the diagram on paper, which whatever I've shown you. Right, you can actually draw that diagram. Okay, this diagram which I've shown you, you can say linear data structures, non-linear data structures. Okay, and linear has stack and queue, and non-linear has the tree and graph. Okay, I think this concept is clear. Okay, now let's look into the next concept called what is an algorithm. Okay, so this is very important. Okay, what is an algorithm? So what is an algorithm? In simple words, if I say, okay, an algorithm is nothing but is step by step, step by step set of instructions. Okay, it is step by step instructions. Fine. So to solve a problem, to solve a problem. Now let's take an example of, let's take a think of a recipe. If to make a tea, okay, to make tea, what are the steps we have? So what is the algorithm you just write? If somebody asks you to write an algorithm to prepare a tea, you say first of all boil the water, right? Boil water. Step 2, add tea leaves. Okay, what is the next step? Next step you add, say, add milk and sugar. And then step 3, step 4 is nothing but you strain and serve it, right? So this is nothing but, what is an algorithm? An algorithm is a step by step set of instructions to solve a problem. Okay, you follow the steps in order. That's an algorithm, right? Now, formal definition, if somebody asks you what is an algorithm, you should say an algorithm is a finite order sequence of well defined instructions. Okay, it should say that it is a finite order sequence of steps. Fine. So we can take one more example. Okay, we can take an example of this. Example of, what if given two numbers A and B. Okay, if somebody asks you to find the larger one, right? So what will happen? What is the problem? Right? Problem is this, and you have to find the larger element between A and B. So how do you find it? Step one, what do you say? Step one, you say just say start. Okay, this is the first step. Okay, you say start. Step two, you compare. Read the values of A and B. Right? What is the step two? You compare. If A is greater than B, then print A. Else, step 4, B is greater. Or you say B is greater. Step 5, you say stop. How simple is it? What we have done here, you notice, what we did notice, it has a start, clear steps, a decision, as well as stop, right? An output. You had start, you had something called definite number of what do you call a clear steps, and then a decision you're making, an output, and a stop, right? So, and just I hope you got what is the concept of algorithm, right? An algorithm is a step by step set of instructions to solve a problem, right? Now let's understand next topic, that is what is a flow chart. Okay, what is a flow chart? A flow chart is, it is a visual representation of your algorithm, of algorithm. Okay, now uh, so instead of writing the, what do you see is, instead of writing the steps in words, what do? You picturize it, you draw the diagram, you draw them using boxes and arrows, right? Right. So what are the standard symbols? Standard symbols are oval, this is used for start and stop. Rectangle, this is for process. diamond is for decision, and arrow is for the way or flow direction, and then you have parallelogram. This is input or output. Okay, so we can take one example, sample example, how to check vision. You can usually check it. Okay, so visually, if you want to check, right, let's draw the visual diagram here. Okay, so what do you say here? Start. Okay, so just we'll take an example of this itself. Okay, so then what are you going to do? You just pick this, and then what are you going to do? You just pick this arrow mark. Okay, you say arrow mark, and then you say this. So what you have done here? This is the oval shape, right? Now next, what do you have to take? You want to take some input output, right? So input output, you can take it as using the parallelogram. So what do you say? Read A comma B. Okay, you are going to read A comma B. Now once you read A comma B, what you want to do next step? Next step, you want to you check whether A is greater than B. Okay, what do you have to do in that step? If you have to take some decision, right? So if you want to take some decision, what you do? You bring diamond shape. Okay, so diamond shape, again, you can, what you can do is, so you just bring this uh, arrow mark here down. Okay, just a second. I think it's better to get it from here itself instead of copying and this thing. You just say reverse. Okay, now based on this, what are you going to do? Here you're going to check whether A is greater than B. Okay, if yes, now here going to take the decision. Right, so one second. So I am just going to pull this. So if A is greater than B, or let me do this way, AB is greater than B, what are you going to do? You're going to say print A, and you say oval. You say stop. Right? So just a second. I think it is just dragging it. Just leave this. Right? You just say reverse. Right? You stop it. Right? And if this is yes, if A is greater than B, you say yes. If A is not greater than B, what are you going to do? You're going to stop here itself, right? You're going to print B, going to print B here, and stop. Right? So I'll just take maybe I'll just reverse this, because arrow flow should show that where it is going. Okay, flow should explain that to which direction the flow is happening. Okay, and then uh, just bring this rectangle or this parallelogram or rectangle. Let's remove this. Just need rectangle, right? So where we can take some processing we are going to do, right? So print B, and you stop it. Right, so whatever we have actually understood as part of the this, right, so algorithm, right, so we just brought this as part of, we have just drawn it as a flow diagram, right? So I think this is clear for you. So it's a visual representation of the algorithm, which will, what will happen when, what will happen, so whatever, so whenever, if somebody, when you're writing a code, right? Okay, the first thing you should do is first draw the algorithm. Okay, first write the algorithm, and then that algorithm, you draw it using the flow charts. What will happen with this? It will it will be very clear. Whatever, if what, I mean, even the flow charts can be understood by a non-programmer also, right? It is very clear, right? So it makes your coding easy, right? I think, I hope this is clear, right? So we can understand, I will give you two or three, I will ask you to draw the algorithms. I'll give you an example at the end of the thing. I'll add it in a chat there, and you can get back to me on the comments. Okay, so I think, I hope this concept is clear now, right? So in the next video, what I will do is, we will understand something called big O notation. What is big O notation, right? So why big O notation is very important. Uh, right, I think that is very important when you are going for an interview, right? That is very very important. Let's learn about big O notation in the next video. So let's do a quick recap here, what we have covered till now. We learned about definition of data structures with the library analogy. We understood what is classification using the primitive and non-primitive data structures, right? Linear versus non-linear. We understood what is algorithm, right? We understood what is flowchart, right? And in the next video, we will learn about we'll understand algorithm analysis, big O notation, and I'll also give you a top interview questions with the model answers for this question things. Thank you so much. Please do add a comment, uh, if you I mean, if you find most difficult, right? Whatever the data structure which you're feeling difficult, I'll definitely make a dedicated video on it. If this video helped you, please hit the like button. It really helps the channel to grow. Okay, thank you. Subscribe and hit the bell icon so you don't miss the next video.